with uniform acceleration, an object with uniform acceleration, traveled 120 meters within 8 seconds, started from rest, traveled 180, 120 minutes within 8 seconds. What is its velocity 15 seconds after it started traveling? Number one, we will get the velocity it traveled within 8 seconds. When it now comes to 15 seconds, that velocity becomes an initial velocity. The initial velocity when it started was 0. Initial velocity at the beginning was 0. That's because it started from rest. It now traveled for a time of 8 seconds. In that 8 seconds, it covered a distance of 120 meters. 120 meters. So, it covered a distance of 120 meters in that 8 seconds. So, within that 8 seconds, we can get the velocity it maintained at that period, at that 8 seconds. To get it, we can use the first equation. The velocity it made at 8 seconds. We use the first equation. V is equal to U is 0 because it started from rest. U plus A. But before we get A, because we want to get A now, we can say, let's get the acceleration. We can now use this, the second equation, to get the acceleration. That is A, because I want to apply A now. A is not in the question, we have to get A. To get it, I use this second equation. Second equation, the distance is 120. Then U is 0 because it started from rest. Then it's equal to half. The time is 8 seconds within a time of 8 seconds. Within a time of times 8 seconds, then times a time of 8 times the acceleration. And the 8 seconds is 8 seconds squared. Half times 8 seconds squared. So we want to get the acceleration. So from here I got the acceleration. Working that out, I got the acceleration to be, that's from there, I was able to get the acceleration to be 3.75. Acceleration A is equal to 3.75 meters per second squared. So I can now bring it here to calculate the first velocity. That's the velocity made in 8 seconds. So to do that, I bring this in 8 seconds. So I have 3.75, which is the acceleration, times time, which is 8 seconds. I get the velocity made in 8 seconds. The velocity the object made in 8 seconds. And that velocity gave me is equal to 30. The velocity is equal to 30 meters per second. 30 meters per second is the velocity made. So this velocity made in 8 seconds. Then we are now told to get the velocity made at 15 seconds. In that case, this velocity becomes initial now. It's no longer final velocity. It becomes initial. Then the final velocity is the one that is after 15 seconds. So this becomes initial velocity. So I can still use the first equation. And now that final velocity is equal to that. That is now initial velocity plus 80, that is plus acceleration, that is 3.75 times time. That time is 15 seconds. Then I got it to be 86.25 meters, 86.25 meters per second. That's the final velocity made. We were told the velocity he made, we got the velocity made at 8 seconds. We are now told to get the velocity made at 15 seconds. Now look at how the question sounds. The question said, an object with uniform acceleration traveled 120 meters within 8 seconds, starting from rest. So it started from rest. What is its velocity 15 seconds after it started moving? What is its velocity 15 seconds after it started moving? An object with uniform acceleration traveled 120 meters within 8 seconds, starting from rest. So if we get the final velocity at 8 seconds. The velocity at rest, well, it should be 0. That is the initial velocity. So when we got that one to be 30, we got the velocity after 8 seconds to be 30. Now the velocity that 30 becomes an initial velocity. Now that we are trying to get the velocity at 15 seconds, we now apply it by making it initial here, and now got the final velocity in 15 seconds. So the question said an object with uniform acceleration traveled 120 meters within 8 seconds, starting from rest. What is its velocity 15 seconds after it started moving? And that is this v equal to 86.25 meters per second. Thank you.